It was very nice.
It was nice in the beginning, like even like I won't, because my parents came to games that like, oh, I'm gonna be on the field, like, oh, I'll come, you know. But wow, it was awful weather. It was, but at least I got it for free. At least it was like a free like game. We went with our school. I feel like I didn't have to pay anything for it.
Alright, we are live.
Right?
So when you just share, just make sure to share your screen whenever you go into Chrome.
Yeah, that's
Good. Sounds good.
Thanks, last thing.
School. Like, I didn't have to pay anything for it. We were live.
Alright, wait.
Maybe you get the audio.
Yeah, I'll try to do that.
So I do that.
Yeah, there's a volume control, so.
Perfect.
Maybe the audio.
Yeah, that sounds good. I don't want to hear myself.
Right. I don't want to see myself. I'm gonna start sharing it. Okay. In case y'all haven't seen, this is the thing now. We have a mesonet.
Ooh.
Have fun.
Also, there's donuts if anyone wants some. Sorry, I gotta take my bag. Thanks.
I don't know what to mean by donut, say another donut Monday.
Alrighty, welcome everyone. First Henry's Memorial Weather Briefing, fall semester, and thanks for coming out. Happy to have Jay Carstens here today. Second year as a postdoc in our department coming from Florida State. So happy to hear about some tropical activity today. And if you want to intro yourself a little bit more, feel free, but take it away. Thanks, Christian, and thanks everybody for coming out.
always nice to kick off the new year and be the guinea pig for the technological stuff. So it seems like everything's working smoothly so far. I'm going to split this briefing up into two parts because, as Christian kind of introduced, I'm the de facto tropical guy around here, and I have to throw in some hurricane lead talk. Tomorrow, I'm giving leading a workshop on hurricane forecasting, Campus Weather Service in the evening. So, encourage you to come out to that for I think what will be a stimulating discussion, because we'll actually have a lot of real-time case studies to kind of look at in the workshop. But I wanted to actually just lead off with this, because if you're not already familiar, we have a Mesonet now that is operational, keystone-mesonet.org. A lot of other states have kind of dished out their versions of these over the years, and it's really cool to see this fully operational with what seems like more than 100 sites statewide, and just to kind of using this to sort of introduce things. We're kind of waking up to temperatures in the 60s and lower 70s across much of Pennsylvania, as you might expect, kind of a warmer clustering over towards Harrisburg and Susquehanna Valley and over towards Philadelphia area. You can toggle this to show a whole bunch of different things. Like we can look at near surface relative humidity. Obviously, you look outside, we got fog, all over the place for the most part, and we're pretty much at RH values in the 80 to 100% range, pretty much statewide. You can even look at things like solar radiation, get a feel for just how much these clouds are blocking some of the sunlight, and that's a bit of a variable story statewide. Some places starting to get a little bit of breaks in the low level cloud cover, but mostly an overcast morning statewide. So again, keystone-mesonet.org. I encourage you to explore this. It's a really cool tool that I think the department will make very good use of in the coming years here. So if you were up super early, or I guess super late or something in the last 12 hours, you might have noticed a kind of persistent shower over State College. And it's been a couple pesky little showers, nothing in terms of significant rainfall necessarily, but still over in east central Pennsylvania. We got a little bit of rainfall activity. Otherwise, pretty much dry across most of the state right now. And the Weather Prediction Center analyzes this, actually the 8 a.m. surface analysis associated with kind of a decaying front that's exiting the east coast of the U.S. right now. And just by looking at this, we can kind of see hints of the next big story for us as we go into the middle and late part of the week, especially with a more robust cold front starting to set up in the Midwestern U.S. In advance of this kind of Canadian high pressure air mass that's going to be kind of building in. So this is just looking at kind of the quasi-analysis from this morning's NAM run, looking at one of the mesoscale models, and you kind of see this little shortwave trough that's set up at 500 millibars over the east coast of the US here. So a little bit of mid-level vorticity kind of working its way off to the east. And if we just kind of let this run over the next 6 to 8 hours or so, we see that kind of in the mid-level levels, we're going to be under this kind of broad area, generally light westerly and southwesterly flow, and a little bit more of a quiescent pattern as we go later on into the day. So we could see still a little bit of light shower activity, kind of an isolated, scattered nature throughout the day, as we still have just a lot of low-level moisture kind of pooled up throughout the state, but not too much in terms of large-scale significant forcing for widespread rainfall as we go later on into the day and overnight. But if we just let this run a little bit further out, we see again hints of our next kind of big weather maker, or big is maybe a bit of an overstatement, but it will at least set up for what I think is going to be a very nice late portion of the week here. As you start to see the southwesterly flow picking up some steam a little bit as we go into the day on Tuesday, and hints of this broader upper level trough starting to move into the area. Just hide the controls here. And this is the upper level water vapor view. This is the College of DuPage satellite and radar page that I just showed earlier in terms of the radar mosaic over Pennsylvania. And you can really start to see this trough start to dig into the upper Midwest and even portions of the Rockies here, with some drier upper level air that will start to filter in behind. And of course, also hints of some rainfall throughout the southern plains and into the Great Lakes region, where you have plenty of moisture in the middle and upper levels here. So this is a big deal for a couple of reasons. One, because it's going to be the thing that really changes our weather as we go into Wednesday, Thursday, and Friday, but also its role in this little guy down here to the southeast. Of course, Hurricane Lee, which has been kind of the big story in the weather world over the past week. We have briefly attained category 5 intensity, and I'll talk more about that and some of the forecast implications for Lee later on, because it is something kind of worth watching at this point for areas like New England and Atlantic Canada. So let's just kind of move forward here, just looking at a couple of the global models and just see the progression of this trough and kind of when we can expect that that weather to really start improving here. And actually have one more thing I want to show, which I'll pull up in a minute here. This is the 6Z GFS run, so the one that ran overnight here, and you can kind of see this trough camped out over the upper Midwest at the first forecast time, which was just a couple of hours ago this morning. And again, here's Hurricane Lee down here in the bottom right of the image here. And I'm not going to play this too long because this is actually kind of one of the scary runs, and I'll get to that in a little bit. But kind of see this trough progressively deepen and start to progress eastward as we go into the day on Tuesday. This is kind of the day where we should be expecting, I think, around State College, at least into the afternoon and evening hours, perhaps our most rainfall in terms of coverage statewide, as this trough continues to sort of progress eastward as we go into the evening time on Wednesday here. And this is going to be around the time when our surface-based cold front passes through in the Tuesday overnight window, it seems like, and might have some lingering moisture and shower activity after the passage of that front before things really start to clear out as we go into the day on Thursday, especially. But I'll play the European run because there's pretty good agreement at this point between the global models, at least in terms of the strength and the kind of eastward progression of the trough. And this kind of agreement is actually going to be a good thing regarding Lee. I'm not sure if some of the Weather Service offices have done this yet, but when I was down in Florida for years, whenever we had one of these kind of TC, potential impacts, the Weather Service offices would tend to launch their radio sounds 4 times a day instead of twice to try to get a better feel for this kind of upstream meteorology that's going to be affecting the steering flow of a storm like Lee eventually. So maybe this has happened. I actually haven't looked into that to this point, but one other thing I wanted to show here is, let's see if I can do this efficiently, because I had this pulled up earlier. So you can get another feel as the GFS here at kind of the frontal passage and when we can expect some of that air, that cooler air to start filtering in by looking at a product like this, which is kind of a mashup on tropicaltidbits.com of temperature advection in the lower or middle levels. In this case, it's showing 700 hectopascals, as well as frontogenesis. So seeing if we have a kind of particularly strong frontal forcing for precipitation or something like that. You would see purple contours there if we're expecting this to be a particularly strong front, like something that you might see with like a nor'easter, for example, later on into the winter time. But nothing prolific, but you kind of see as we play this forward that we start to see some of these blue shadings popping out as we go into the day on Tuesday, and some hints of the mid-level and lower level winds starting to turn to more of a northwesterly component as we go through the day on Wednesday. And this is really the time where we should start to see that cool down and that drier air starting to filter in out of the northwest through a deep layer of the atmosphere. Again, Wednesday, we should have some kind of lingering low level moisture that will contribute to some continued cloudiness and potential for some scattered showers still throughout the state. So it's really Thursday. I think that's the day where it's going to feel like fall. And I'm personally very much looking forward to it, because if we kind of just look back at some of the observed weather in the area, obviously last week was pretty profound for some of the heat that we saw, really throughout the state, where I believe this is the University Park Airport site, recorded temperatures near 90 degrees 4 days in a row last week. So some pretty intense heat for September, things that I'm more accustomed to, coming from where I was down in Tallahassee, Florida. But just kind of looking through, what the expectation should be temperature-wise, our sort of daily almanac for today statewide. We should be seeing temperatures kind of in the lower to middle 70s for afternoon highs and average lows around 55 degrees or so. So starting to regress to the mean a little bit in that sense. And a little bit of cause for optimism here. If we just look at the national blend of models, this is valid Thursday morning. You can kind of see some widespread lower to mid 50s throughout much of the state after that cold front works its way through, and could see some spots dipping down into the 40s Wednesday as well as Thursday evening. This map actually shows properly. Then I'm going to pull this ahead to 18Z on Thursday, where afternoon highs are forecast to not even crack 70 degrees here in State College. So I think NWS current forecast is about 68 for Thursday afternoon. So that's going to be the day where I think we're going to be really happy. So I'm going to pause at this point. If anybody wants to correct me on anything or just kind of saw anything that was interesting and you wanted to point out, I'll leave the floor open for a little bit of conversation here before I shift over to Hurricane Lee. Yeah, Bill.
Jake, I haven't looked, and I don't know if you have,
Yeah.
when we shipped to Northwestern Mall, are there still fires in Canada? Are we worried about smoke?
Let's see. I'll try to pull up the smoke product on Pivotal. Assuming that I'm not behind a paywall, which is certainly possible. Run. Sorry, I don't know what I'm doing with this thing. This through. Not a perfect product, but one that should be a good proxy of whether there's significant wildfire activity or not. Doesn't seem like it. So that's promising. Might actually have some blue skies.
Awesome.
I'm a little bit overly pessimistic about that. We've had some pretty nice days in August, but man, summer was. If y'all weren't here over the summer, man, that was something else. I don't think I saw a clear blue sky for 3 months, and some of the stuff we had here in June was like what you would think the Dust Bowl was like. Some parts of the Northeast, it was pretty intense actually. Anything else on local? Okay, let's get tropical. All right, so Hurricane Lee. Again, consider this to be kind of a teaser for the hurricane forecasting workshop that will, hopefully I'll see some of y'all at tomorrow. This is Hurricane Lee right now. This is just the visible satellite product from the same College of DuPage website. It's currently located to the northeast of Puerto Rico. So I think there's actually been a really successful iteration of kind of model track forecasting so far. It's been very consistent on this kind of northwestward track since the wave initially exited off of the African coast. And while there was some, I guess, trepidation about, whether the northern Lesser Antilles and areas like Puerto Rico and Hispaniola were going to see some sort of impacts. Thankfully, the state north and only delivered some swells, basically some pretty high wave activity, and also recurrent risk is something to kind of keep in mind for pretty much the entire east coast of the U.S., regardless of whether or not this kind of gets close to New England. Lee at one point attained Category 5 intensity. I think I said that already, but so when you kind of factor in Ian getting upgraded to Category 5 in postseason analysis last year, I think it's like the 7th or 8th Category 5 we've had in the last 8 years in the Atlantic Basin. So, but you kind of see right here, it's, for a storm that's currently assessed as Category 3 hurricane, and I think probably will maintain Category 3 status at the next advisory. Maybe it'll get bumped down to a high end too, but I think it'll stay at 3. You don't see that clear-cut, clear eye, but you do see kind of hints of these little inner core convective bursts that are trying to wrap around the center. Lee has struggled with dry air and wind shear over the last couple of days, which has helped to lower it from that Category 5 peak. And there's hints that some of that wind shear has relaxed a little bit. If you look really closely at this loop, you can see these cirrus clouds aloft that are rotating clockwise, anticyclonically. And one of the big things that we noticed a couple of days ago was that was really restricted on the south side of the storm, indicating that we had some deep layer wind shear out of the south and southwest that was kind of disrupting the kind of vertical stacking of this vortex, basically. And it's not as, it's not perfectly symmetric, this outflow pattern, but you can kind of see hints of it extending, maybe a couple 100 miles away from the storm center here. So basically the Hurricane Center, I'm not going to dive into the specifics of their forecast necessarily, but they are calling for some additional intensification, potentially again into a low end Category 4 hurricane before it starts to enter cooler waters. Let's jump ahead and look at some of the Hurricane Hunter reconnaissance data, and I'll point out a couple of features that I think are interesting from this. So this is just tropicaltidbits.com, kind of the classic home base for Hurricane Hunter information. It looks like there's an Air Force plane leaving now from Biloxi that'll be there, actually probably in a couple of hours. I'd imagine that's a pretty long flight over there. But there is a couple of, well, one mission that just finished up and one from the NOAA low-level aircraft that is still ongoing here. So a few things that kind of jump out immediately: the pressure, which is kind of fixed by these data messages that the planes transmit to the Hurricane Center. Holding the pressure approximately steady around 950 hectopascals, so not the significant strengthening that we maybe saw 3 or 4 days ago with Lee. The wind field is growing, certainly. You can kind of see these purple wind barbs that are extending, almost 2 degrees longitude now away from the storm. So we're getting to like 150-ish miles away. And this is at the flight level, which is, about 10,000 feet or so above the surface. So maybe not a perfect indicator of what's going on near the ground, but a hint that at least tropical storm force winds are starting to expand to a much wider range. And that's kind of what we expect, both when these storms start to approach higher latitudes and become a little bit more extra tropical in character. But also another big thing here is eye wall replacement cycles. So hurricanes, when they kind of get to this category 3, 4, or 5 status, they tend to develop these sort of outer secondary eye walls that eventually contract and kind of become the new eye wall, essentially. And there's a lot of really cool research being done in the department by Anthony Didlake and his students, for example, that kind of studied the dynamics of how all this happens. So if you really want to get nerdy, I encourage you to read some of Dr. Didlake's papers. But some hints that you can see on the recon observations that hint at this. Look at the wind line here shown in blue compared to the pressure. So we kind of see these passes through the center when the mean sea level pressure graph dips down to about 950 hectopascals or so. But at the same time, you kind of see these double peaks in the wind speed. And that's a perfect indication that one of these secondary eye walls is formed. And what you can start to see over time is actually this outer eye wall is starting to become a little bit dominant, because this kind of maximum in the wind that's farther away from the center, at least in terms of what the time series is suggesting, starting to show that those winds that, maybe 100 kilometers away from the center or something like that are starting to become the main winds and kind of choke off some of that inflow to the inner eye wall of the storm. You can also see this in the SFMR product, which is basically an instrument attached to the plane that tries to detect what the surface winds are like, based on some of the properties of seawater down near the surface. So a secondary peak also kind of showing up near the surface as well, which is kind of lagging behind what's going on at the flight level here. So in general, it looks like the peak winds assessed by the aircraft are at flight level about 105 knots, which would be about 120 miles per hour. So the wind speed seems to be, in terms of its max value, reduced slightly from what the Hurricane Center had in their 5 a.m. advisory, given that, this is usually a little bit higher at this level compared to what you see at the surface. But these eye wall replacement cycles, they oftentimes get communicated as a weakening influence on the storm. And while that's true in terms of the maximum winds, I think it's a little bit of a slippery slope. It's really more of a redistribution of the kind of kinetic energy that a hurricane's wind field has, because this usually means that the storm gets larger. And we've seen this in the kind of couple of iterations of these cycles that the storm has already undergone. So we'll see what the Air Force plane reports when it goes back in a little bit later on. But one other thing I wanted to show was this mission here. This is NOAA 9, which is actually the upper altitude aircraft that flies about maybe 40,000 feet or so above the surface. And you notice that it doesn't actually go right into the teeth of Lee. These planes actually don't, they typically avoid the centers of category 2 or stronger hurricanes. It's kind of the de facto rule of thumb that they use here, because of kind of upper level wave activity that makes it a little bit perilous to fly close to the center of the storm. But what this kind of mission is particularly useful for doing is deploying drop sondes that can sample a deep column of the atmosphere, basically just a reverse weather balloon that descends down to the ocean surface, and it gets a feel for what's going on in kind of the outer storm environment. One of the things that stuck out to me kind of looking at some of these drop sonde soundings, I'm going to pull up sonde number 20 as an example, and you can kind of see this belt of dry air that's especially poignant around, say, 400 to 500 hectopascals. So thermodynamically, it's not a perfect environment, I think, for Lee to intensify significantly. And I think that's gonna, if that can kind of get, wrap its way into the inner circulation of the storm somehow, then that can be something that could weaken it even in the short term, or at least limit its intensification. So that's why the Hurricane Center hasn't called for this to strengthen beyond another 5 or 10 knots or so in terms of its max winds. So I'm not going to show the cone. Instead, I'm going to show this product, which is kind of an overlay of 2 different fields. The most likely arrival time of tropical storm force winds, or kind of when you could expect, 34 knot or stronger winds to start occurring at your location. And the shading here is just the probability that a given location is going to receive these sustained winds at any point. And it's, time to start watching, I think, if, for areas of New England, especially along the coastline here, because while areas outside of Cape Cod are not necessarily in this zone yet, there has been, at least a non-negligible number of ensemble model solutions that have suggested potential impacts to portions of New England. There's been a lot of kind of clickbaity headlines about like landfalls in New York City and stuff like that. And I don't think that's going to verify by any means, but I do think it's time to start kind of watching how the forecast evolves over the next couple of days or so for, say, areas like coastal Maine, and especially over towards Atlantic Canada, where I think there's a little bit more confidence that some sort of impact outside of maybe just the rip current thing could be a factor here. So this is kind of one of the, I kind of teased this earlier. This is one of the sort of scarier individual model runs from the GFS that shows a possible scenario where it could be more direct impact towards New England. And one of the things that I think is interesting here is you kind of see, this is looking at the geopotential height field in terms of the anomaly. So the blue is basically just kind of areas of anomalous troughing or low pressure. And this storm over here is actually Tropical Storm Margot, which as 5 a.m. was a high-end tropical storm and is forecast to intensify into a Category 1 hurricane as it kind of drifts towards the north. So you'll see that. Right now, Lee is kind of blocked by an elongated subtropical ridge that's not allowing it to really progress quickly to the northwest anymore. Some of that steering flow has really slowed down over the last couple of days. And as we let this play, you'll eventually see that ridging start to weaken, and also the trough that's going to bring us some of that cooler and drier weather is going to start to have a significant influence on how Lee moves. So you kind of see that weakness in the ridge, and then Lee starts to gradually lift northward over the next 3 days or so. So we let this play to about 72 hours. This is overnight Wednesday going into Thursday. You can kind of see this phasing of the trough with Hurricane Lee at this point. Now, this model scenario in particular produces a pretty strong iteration of Margot that actually I think would attain Category 2 intensity approximately if if you use kind of a typical range of what the sea level pressure looks like first from this thing was depicting about a 960 millibar hurricane for Margot. And what kind of happens here is because Lee is moving pretty slowly, the trough almost not necessarily outpaces Lee. But at the same time, you kind of see this re-strengthening of the ridge at higher latitudes around, say, 45 degrees north or so. This particular model run kind of takes it, not a hard left, but kind of a little jog to the west before kind of moving up towards coastal Maine. And at this point, it's worth noting that the maximum winds of a storm like this would pretty much, unanimously weaken as it moves into an environment of cooler sea surface temperatures. But this would be a much broader wind field, and this particular scenario would have, some non-negligible impacts to again areas of New England, potentially significant. So this is still the kind of minority scenario here. I think most, and I'll show this in terms of the ensembles in a second here, but this particular solution of a stronger Margot, a stronger ridge pattern in between the two storms, and some kind of subtleties in terms of how Lee phases with the trough that's going to be passing through here are going to be all of the, that's going to paint a pretty significant story over the next 24 to 48 hours or so. So I'll move ahead to the ensembles here because that was just one run, and it's a little bit irresponsible to only be showing one run here. This is the European ensemble where I've overlaid the sea surface temperatures. And this particular feature is a little interesting north of Bermuda. And I should note that, Bermuda needs to keep an eye on this as well. Because this is actually a kind of region of cool sea surface temperatures left behind after Hurricane Franklin about a week to 10 days or so ago. It was a slow moving storm, and as these hurricanes kind of extract that fuel from the warmth of the ocean, what they do is they kind of upwell or pool up cooler subsurface ocean water, kind of leave that at the surface here. So this 26 Celsius isotherm is still, it's not something that would, totally not support hurricane intensification, but this is something that will be a bit of a limitation on the intensity of Lee as it kind of progresses northward here. So I'll play this forward here, and this run of the European from last night depicts a slightly weaker Margot, and then also has a little bit more of a kind of quick move up to the north. While some members do try to nudge the storm back to the west, you'll note that at this time, an extratropical transition would be taking place as the storm will be entering an area with a significant meridional temperature gradient, and in general, just much cooler waters. It starts to draw more of its fuel from this kind of baroclinic environment as opposed to this deep tropical warmth. So kind of let this play forward again, something for Atlantic Canada to kind of watch significantly, as well as again, some potential subtleties in how this forecast might change for areas of southern New England up towards Maine in the next couple of days. So the timing of this is actually interesting because here I'm wearing my Florida State shirt, and then this particular, this time step in the Euro would be at 18Z on Saturday, and Florida State's playing Boston College that afternoon. So yeah, maybe time to start thinking about the potential backup plans to move that game in case some of these members verify a little bit here. So the GEFS, I'm just showing the same temperature plot from before, but in terms of the anomaly. So you actually do see below average sea surface temperatures in the Atlantic for like the first time ever this year in this part of the basin, again, where Franklin passed through. So this is valid as of 18Z Saturday. And again, most of the members don't necessarily take that hard left. And there's actually only one that actually makes a landfall in Massachusetts. But at this point, the size of the storm would be large enough that even if it is 100 miles offshore, it's something to consider, at least in terms of potential tropical storm force winds and otherwise just significant, wave activity, recurrent potential on the beaches and so on. So in terms of timing, I think this weekend is kind of, if there are impacts to portions of New England, it would be over the weekend. But there is still, I think, a lot of detail that we need to sort of work out. So we'll see where we're at even tomorrow night when we kind of do this workshop. This is just another kind of visualization of that cold wake left behind by Franklin, looking at the sea surface temperature anomalies in the area of Bermuda here. So you see this widespread belt where you have maybe a degree Celsius cooler than average. And again, that's 75, 80 degree sea surface temperatures, which is still warm enough to support a storm like this, at least not totally petering out, but could at least lower the ceiling before that extratropical transition starts to take place. So I'll wrap up by just showing the 7-day outlook, because after Lee and Margot, Cabo Verde season doesn't quite look to be over yet. We got another wave we're watching that just exited the African coast. It's in a bit of a complex kind of convective environment, but something that, maybe when we revisit a discussion like this next week, that, could be something to at least keep an eye on, or at least gawk on satellite imagery over. So I'll wrap up there. I think I left some time for discussion. And if you want to talk about anything tropical related or going back to some of the state college weather, I will open the floor here. So thanks. Yeah,
Jake, I just want to say, because I know we were talking about it earlier, I know you guys Caribou just said they're going to start doing 4 balloon launches every 6 months.
good. Okay, I figured. Yeah, Marissa.
How rare is it for a storm to make landfall coastal?
Let's see. If y'all haven't seen this, this is a cool website called NOAA's Historical Hurricane Tracks, just coast.noaa.gov/hurricanes. I will note at this time, it's certainly possible that this could have already been deemed extratropical. So there's actually a lot of storms that kind of pass through. Let me filter out the extratropical cases. So it's actually a decent bit of storms that in the historical data set at least passed over Maine and were still considered tropical in nature. How tropical they are is probably an open question. And I don't have a great feel for kind of the case by case, but like you can see like Bob 1991. Arthur kind of passed near, but was undergoing transition. Yeah, so it's not totally unprecedented, but at that point, we're talking about going into an environment with, 6 degrees Celsius SST gradient, not even the width of Maine. So, yeah, could be interesting in that case. Yeah, Ben.
Not a question, just more of a comment. I know a lot of New England Mets are starting to at least mention this too, that over the last 60 to 90 days, a lot of eastern New England's had 18 to 24 inches of rain. So even if the storm stays far enough offshore, even a few tropical storm force wind gusts over land on saturated soil like that could cause some problems that might not otherwise be there. So
Yeah, and one of the things that's that's kind of useful to keep in mind here too is as these storms kind of undergo their extratropical transition, that sector where the heaviest rain falls starts to shift. It's less right of motion and becomes more kind of forward facing, right? And so even a storm that again might be 100 miles offshore, you could still have a more significant component of that heavy rainfall in the inner core or kind of adjacent to it that starts to shift a little bit westward. So that's a good point. And for anybody, I don't know if anybody's watching YouTube or anything, but I think I should probably just step in and say that I'm not at like a, rush to completion stage or anything. This is definitely at the wait and see, tune into the forecast. We'll see where we're at on Wednesday with something like this, because I think there's a lot of details we have to work out still, but some sort of impact to New England can't be ruled out at this point. Yeah.
Could you elaborate on what's causing these leftward steering of the story?
Yeah, it's been kind of hard to pick apart, at least in the time that I had this morning to prep this. Part of me is kind of curious about. So one of the things you can do, and this might be kind of ad-libbed, and I'm not sure if I'm going to get any actually useful info out of this, but on Tropical Tidbits, what you can do is kind of do like a run to run, kind of see how things are changing. There's a lot of consistency in terms of the forecast location of the. I'm trying to look for some subtle details in terms of the trough amplitude and location. What's going on with Margot and the ridging. And it does seem like there's some kind of westward nudging of Margot and and the ridging in between the two storms. But yeah, I wish I had a better answer for you on this. But there's a lot of complicated details to kind of sift through. So maybe I'll have a better feel for this tomorrow, and I can record like a 2-minute snippet of the workshop and and send it out. But yeah, I think this is really a kind of a 4-tiered issue with our trough, the kind of current progression of Lee, Margot's strength, and kind of what's going on with this ridging up here that we all kind of need to consider. And that's why these 4-day launches, I think, from offices like Caribou are actually going to be really important, along with these continued upper level drops on missions. Because the whole point of these sort of things is to get things like the thermodynamic environment, but also some of the nitty gritty details of the steering flow at different levels of the atmosphere that can get fed into models like this, and hopefully nail down a solution. But just one kind of side note, I think it is really cool how consistent the track forecast has been from a lot of the global models, so really from all of them to this point. There's been a lot of details about the intensity that they've struggled with. Because there's just a lot of storm scale processes, especially in like a Cat 5 hurricane that can, cause these pretty quick fluctuations. But I think it's been a really well forecast storm so far, in terms of its journey from Africa to where it is now. So, yeah.
Is it still amazing to you as a hurricane person when we get storms that basically double the rapid intensification requirement
I mean,
or come close to it at least?
I think 2020 was like, if any like time of, I'd say 2020 was like the time where I was really starting to like get into this. Like I was doing TC research early on in grad school, but I think 2020 is really when I started to kind of get into like the forecasting world a little bit, at least through like social media. And I just feel like there were so many RIs that year that it almost desensitized me. So I almost kind of expect things like this to happen sometimes. Yeah, like this challenged like Wilma in a way. Like Wilma was, I mean, just next level in terms of its pressure drop. But if anything, it's I mean, kind of yes and no. Like the RI episode is very, very well forecast. And it was the first time I think ever that the Hurricane Center explicitly forecasted a Cat 4 in their first advisory from the tropical depression stage. But yeah, like there's just a lot going on at, meso beta, like kilometer scale convective processes that I think we still have a lot of work to figure out. So, yeah.
So maybe you partially answered this already, but if it went more west versus going more east, how would you say it would affect its like status being like a hurricane or possibly tropical storm later on in its development?
Yeah. This is a very good question. I don't think it would be a significant effect on like the actual intensity. Because I think this sea surface temperature gradient that we're kind of looking at is a weakening influence, and then something that's going to kind of cause the character to start to be a little bit more extra tropical. It's just very kind of meridionally fixed. I mean, and I think the kind of turn to the west of Bermuda here and entering this Franklin cold wake is, thermodynamically, it's pretty consistent. I'm kind of rambling here, but I don't think it would be like, you can see sometimes in models where like a stronger storm goes more north or something like that, because it feels different, steering influences different altitudes. And that could be a factor that I admittedly haven't looked into with great detail, but I don't think it's going to be significant in terms of the intensity, if that helps.
Thank you.
Anything else? Yeah, I know. I really got carried away with the tropical of this, but it's kind of inherent.
That's what we're all thinking about. Yeah, and that's. Anything else, man?
Stuff on.
Thanks, Rick.